Welcome back, deep divers. Today, we're taking a different approach to the search for extraterrestrial life.
Different how?
Well, instead of tuning into radio signals, we're looking for something else, something that might hint at advanced civilizations.
Intriguing. What kind of something else?
Think bigger. Think energy. Think, maybe, solar panels.
Solar panels, like giant space-based solar farms.
Exactly. We're diving into the idea that we could actually detect these artificial spectral edges
Yeah.
light years away.
That's pretty wild. Like, we could spot ET's energy grid from Earth.
You got it. It's about looking for the unintended consequences of a civilization's technology.
Right, like a civilization's energy use can tell us a lot about how advanced they are.
Exactly. And speaking of advancement, you know about the Kardashev scale, right?
Of course, it's how we classify civilizations based on their energy consumption.
Right. A type by a civilization, for example, can harness all the energy of their home planet.
And a civilization with massive solar farms would definitely fall into that category. Pretty cool, right?
It's mind-blowing. So instead of waiting for a message, we could just, see their energy signature.
It's a fascinating concept. And there's actually a paper that dives deep into this.
Oh, really? What's it called?
Natural and artificial spectral edges in exoplanets.
Okay, so this paper, is this where we're getting all our intel for this deep dive?
It's one of our main sources, yeah.
Yeah.
Really thought-provoking stuff. So to understand this whole thing, we got to talk about the kinds of planets where we might find these solar arrays.
Okay, so what are we looking for? Any planet will do.
Not quite. This paper focuses on tidally locked planets.
Tidally locked. Remind me what that is again.
One side always faces its star, constant daylight. The other side is perpetual night.
Ah, right, like how the moon always shows us the same face.
Exactly. And these tidally locked planets usually orbit M-dwarf stars, which are smaller and cooler than our sun.
Okay, so why are these planets so special for solar panels? Seems kind of obvious, but I want to hear you say it.
Well, think about it. Constant sunlight on one side means a civilization could maximize their solar power.
Right. Prime real estate for a solar farm. And didn't I read somewhere that scientists think life on these planets might cluster near the Terminator?
You're exactly right. The Terminator is that zone between the day and night sides, where you might get the best of both worlds.
Light and more moderate temperatures. Makes sense. Now let's get into the nitty-gritty. What are these hypothetical solar panels made of?
Well, the authors of this paper really get into the weeds about the material. Their best guess: silicon.
Silicon. Why silicon? I mean, yeah, we use it here, but is there something special about it for aliens too?
It's more than just familiarity.
Right.
Silicon is super abundant throughout the universe, and it's really good at converting sunlight to energy, especially around stars like our sun.
That makes sense. But hold on. Wouldn't silicon be less effective around those cooler M-dwarf stars?
That's a good point. The paper does mention that silicon might be less efficient around M-dwarfs, but it also suggests some workarounds.
Workarounds like what?
Things like concentrating the starlight to make it more intense.
Yeah.
The main takeaway, though, is that silicon have a unique property.
Mm-hmm.
It becomes much more reflective in the UV part of the spectrum.
So kind of like how plants create a red edge by reflecting red light differently.
Precisely. It creates an artificial edge that we could potentially detect. And get this, it's not just silicon.
Oh, really? What else could we be looking for?
The paper also shows these reflectance graphs for gallium arsenide and perovskite solar panels. They all create that distinct artificial edge.
So basically, aliens could be using a whole bunch of different space-age solar tech, and we could, see the fingerprints of it in the light.
Exactly. It's like looking for a specific color in a rainbow.
This is also fascinating, but I have to wonder, how do we even know what to look for first? And how do we make sure we're not just seeing something natural and getting all excited for nothing?
Excellent questions. We've got to be careful not to jump to conclusions. But before we dive into that, let's focus on what this artificial edge could tell us if we did find it.
Okay, so let's say we do detect this artificial edge from some distant planet. What could we learn from that?
A lot, potentially. For starters, we could figure out how much of the planet is covered in solar panels.
Wait, seriously, we could actually tell how much of a planet is covered in solar panels just from the light?
The paper even has an equation for it. It's equation 3, I think. It helps us estimate how much energy they're harnessing.
Whoa. So we could potentially figure out their energy consumption and then maybe even place them on the Kardashev scale, see how advanced they are.
Exactly, but it goes even deeper than that. It's not just about the numbers. It's about what those numbers tell us about them.
What do you mean?
Think about it. Their energy use could give us a glimpse into their values, their priorities. Are they using energy sustainably? Or are they exploiting their resources?
Wow, that's deep. Just by looking at their energy choices, we might learn something about their culture. But this brings up another question. How much solar panel coverage would we actually need to see a signal?
You're right, that's a key point. A few panels here and there probably wouldn't be enough. We'd need something more substantial.
So, like, how much are we talking? Half the planet.
That's where equation 2 from the paper comes in. What's really cool is that even a small percentage of a planet covered in panels could create a noticeable contrast.
Wait, so we wouldn't need a planet completely covered in solar panels to know something's up?
Exactly. We're not talking about a Death Star situation here, just a detectable shift in the light.
That's incredible. So even a little bit of coverage could be a clue. Okay, I'm hooked. Tell me more about what they might be doing with all that energy.
Well, one idea that the paper explores is terraforming. And let me tell you, the possibilities there are mind-boggling. Terraforming. It's like taking an entire planet and reshaping it, making it more suitable for life.
Okay, so we're talking full-on planetary engineering here. Could they actually make a whole planet habitable?
Well, theoretically, yeah. Imagine a tidally locked planet, one side always facing its star.
Right, the super hot side and the super cold side.
Exactly. They could use all that solar energy to redistribute the heat, like move energy from the hot side to the cold side.
Wow, so they could balance things out, make the whole planet more temperate. That's amazing. But would we be able to see that from Earth? Like, how would we even know they're doing that?
Think about it. You're looking at the light from this planet, and you see vegetation.
Vegetation, okay. But on a tidally locked planet, wouldn't plants only grow on the side facing the star?
That's the thing. What if you see plants growing on the side that's supposed to be in perpetual darkness?
Whoa. You're saying they could be using artificial light to grow stuff on the night side, powered by their giant solar farms.
Exactly. That kind of anomaly would definitely raise some eyebrows. It'd be a pretty big clue that something unnatural is going on.
Okay, that would be a pretty strong hint. But what if they're not into terraforming? What if they're using all that energy for something else? Like what?
Well, the paper also mentions the possibility of detecting abandoned solar rays.
Abandoned, like they built this huge solar energy infrastructure and then just left. It's a possibility. Imagine remnants of a civilization, long gone, but their solar panels are still there, harvesting energy.
Wow. That's kind of eerie, but also really cool. Like, we could be looking at the ruins of an ancient alien civilization.
Exactly. It's like interstellar archaeology. We could be piecing together the history of these civilizations just by looking at their energy infrastructure. And think even bigger.
Bigger than a whole planet covered in solar panels. How much bigger can we go?
Solar rays wouldn't have to be limited to planets. They could be on moons, right?
Moons, yeah, good point. But wouldn't those be harder to detect?
Probably. But the paper even mentions the possibility of finding solar arrays on, get this,
Yeah.
artificial megastructures.
Megastructures. Okay, now we're talking science fiction, like what? Death stars.
Named Dyson spheres.
Dyson spheres. Oh, right.
Yeah.
The ones that completely enclose a star to capture all its energy.
Exactly. And remember that paper by Lingham and Loeb from a few years back?
The one about using Dyson spheres to power beacons and stuff? Yep, that's the one. They explored the idea that civilizations could be using these megastructures to send messages across the galaxy.
Or even to, like, propel themselves through space using light sails, right?
Right. Pretty wild stuff. But it's all theoretically possible if you have enough energy. And these Dyson spheres, well, they'd be a pretty obvious sign of an advanced civilization.
Okay, so we've got planets covered in solar panels, abandoned arrays, and now giant Dyson spheres. This is getting pretty mind-blowing, but let's be real here. Do we even have the technology to see any of this?
We're getting there. Telescopes like WFIRST and LUVOIR, which are planned for the future, are being designed with the sensitivity to potentially make these kinds of observations.
Okay, so the telescopes are coming, but wouldn't it be hard to actually pick out these signals? Like, how do we know we're not just seeing some random blip in the data?
That's the challenge, right? We need to filter out the noise, make sure we're not mistaking a natural phenomenon for something artificial. It takes a lot of careful analysis.
Sounds like finding a needle in a haystack.
In a way, it is. But the potential payoff is huge. Imagine if we could definitively prove that an artificial spectral edge exists.
That would be huge. Like, game over huge. We'd know for sure we're not alone.
It would change everything. Our understanding of our place in the universe, our whole perspective on life itself.
Wow. That's heavy stuff. But you know, it also makes me wonder, what if we find a civilization that's like way more advanced than us? What would that mean for humanity?
That's the million-dollar question, isn't it?
Well,
Some people think it'd be the best thing ever. Imagine the knowledge we could gain.
yeah, but others are more cautious. Like, what if it's not a friendly encounter? What if they see us as a threat? I mean, we haven't exactly got the best track record with first contact here on Earth.
That's true. It's a double-edged sword for sure. We'd have to be really careful. But there are even bigger questions at stake here.
Like what?
Like, what does it say about our place in the universe if we find another intelligent civilization? It challenges our whole idea of being special, unique.
Yeah, that's a pretty big blow to the ego, realizing we're not the center of everything. But in a way, it's also kind of liberating, right? Knowing that we're part of something much bigger than ourselves.
Exactly. And who knows, maybe they've figured out things that we're still struggling with. Sustainable energy, interstellar travel, maybe even the meaning of life. Finding them could open up all sorts of possibilities.
It's almost too much to comprehend. But hey, let's not forget about those other materials we mentioned, gallium arsenide and perovskite. What makes them so special for alien solar panels?
Well, gallium arsenide is really good at converting light to electricity, even better than silicon.
So it's super efficient. But why would aliens choose that over silicon?
It's really durable, perfect for harsh environments like space. And perovskite, that's a newer technology, but it's got some amazing
Oh,
potential.
yeah, I've heard of that. It's supposed to be really cheap and efficient, right?
Exactly. And the cool thing about perovskite is that you can tune it to absorb different wavelengths of light.
So they could adapt it to different kinds of stars.
Exactly. Their solar panels could be optimized for their specific star system. Pretty clever, huh?
Very clever. But this all makes it even more challenging, right? I mean, we're not just looking for one specific signal, we're looking for a whole range of possibilities.
That's where the power of computers comes in. We're using algorithms and machine learning to help us analyze all the data, looking for those telltale signs.
So it's like having a team of digital detectives sifting through all the cosmic noise, trying to find those hidden clues.
Exactly. It's a huge task, but that's what makes it so exciting.
Yeah, the thought that we could actually be on the verge of discovering another civilization, it's mind-blowing, but it also brings up a whole bunch of ethical questions, like what are the implications of finding another intelligence out there?
That's a whole other can of worms.
Mm-hmm.
But it's something we need to start thinking about seriously. The search for extraterrestrial intelligence isn't just about science and technology. It's about our place in the cosmos, about what it means to be human.
It's a lot to wrap our heads around, you know. We've been talking about planets covered in solar panels, abandoned alien megastructures. It feels like we've gone from science to science fiction in just a few minutes.
I know, right? It really stretches the imagination. And as we keep digging into this search for extraterrestrial intelligence, the questions just get bigger and bigger. One thing that's really been on my mind is the concept of time.
Time. Okay, I'm listening.
Well, we're looking at these distant stars and planets, but the light we see, it's from the past. It could be hundreds, even thousands of years old.
Oh, right, because it takes time for the light to travel all those light years to reach us. So we're seeing these planets as they were a long time ago, not as they are right now.
Exactly. We could be looking at the remnants of a civilization that's long gone, or one that's advanced so far beyond us that we can't even comprehend their technology.
Whoa, imagine that. We find this artificial spectral edge, proof of an alien civilization, but it's millions of years old. What would that tell us about the fate of civilizations? Could it give us a glimpse into our own future? Maybe a warning about the dangers of technology or the fragility of civilizations in the face of, cosmic events?
It's definitely a possibility. But even if we were to find evidence of a long extinct civilization, wouldn't there be something beautiful in that? Knowing that we're not the only species to have looked up at the stars and wondered, to have dreamed of reaching out into the cosmos, even if their time has passed, it would mean that we're not alone in the grand scheme of things.
You're right, there's a certain poetry in that, a bittersweet kind of beauty. But, it also makes you appreciate the present moment even more, knowing how fleeting everything can be.
Exactly. It puts things into perspective, doesn't it? But hey, let's shift gears for a second. Remember how we were talking about gallium arsenide and perovskite as potential materials for alien solar panels?
Yeah, those super efficient space-age materials.
Well, those materials have properties that make them really interesting for us here on Earth, too, especially for things like space-based solar power.
Oh, you mean like building solar power stations in space and beaming the energy back down to Earth? That's been an idea for a while, hasn't it?
It has, and it's gaining traction. Studying these materials and how a technologically advanced civilization might use them could give us some valuable insights.
So even if we don't find definitive proof of aliens, this whole search could lead to breakthroughs in our own technology. That's pretty cool.
It is. It's a reminder that the search itself is valuable, even if the ultimate goal remains elusive. It pushes us to think outside the box, to challenge our assumptions, and to explore new frontiers of science and engineering.
It's like that saying, it's not the destination, it's the journey. Okay, so we've talked about the possibilities, the challenges, the ethical questions. But let's be real. What are the chances that we'll actually find an artificial spectral edge, like in our lifetime?
That's the million-dollar question, isn't it?
Mhm.
The universe is vast, and the signals we're looking for are incredibly faint. But new telescopes are coming online all the time, and our ability to analyze data is getting more sophisticated by the day. I'd say the odds are definitely in our favor, but it's hard to put a time frame on it.
So it's a waiting game, but an exciting one for sure.
Absolutely. And when that day comes, when we finally detect that telltale signal, it will be a moment that changes humanity forever. It will force us to confront our place in the cosmos, to rethink our assumptions about life and intelligence, and to embrace the unknown with a sense of wonder and perhaps a healthy dose of caution.
Well said. It's both exhilarating and a little bit terrifying to think about, but that's what makes this whole search so compelling. So, deep divers, that's about all the time we have for today. We've explored the fascinating world of artificial spectral edges, the potential signs of advanced alien civilizations, and the profound implications of this search for humanity.
We've covered a lot of ground, from silicon solar panels to Dyson spheres, and we've only just scratched the surface of this incredible field of study.
So, keep looking up, keep asking questions, and never stop exploring the universe and all its mysteries. Who knows what we might find out there? Until next time, deep divers, keep the curiosity alive.